Hey everyone, I thought I will just make a short video on explaining how the VantHoffFactor works and how do you determine it, and also how it affects the colligative properties like boiling point and freezing point. All right, so here are a few chemicals, calcium chloride, and the middle one is glucose, then nitric acid, HNO3, sodium sulfate, and carbonic acid. So I just took a variety of chemicals here just to show you how things work. So the thing about colligative properties is that colligative properties works on the number of particles that you have in solutions. So which means the first thing we need to determine for all of these is the number of particles. So for calcium chloride, when you dissociate that in water, so you'll end up getting calcium ions and then 2 of chloride ions, which means that you have a total of 3 ions in solution. When you take C6H12O6 or glucose in water, because glucose is a molecular compound, it's a covalent compound, you don't get any ions. So just because you don't get any ions doesn't mean there is no molecule in water. Glucose definitely dissolves in water. So which means it is just one molecule. All right, I'm not going to write ion because it's not an ion. Ions would be positive and negative, right? So I'm not going to write that. So it's just one molecule. It is dissolved in water. Now for HNO3, HNO3 is a strong acid. When you take that, and actually HNO3 acid exists only in water. So if it is in water, you're going to have H plus ion and then a nitrate ion, which means that this is a total of, yes, you guessed right, 2 ions, okay, in there. So you do that for all of these compounds. Sodium sulfate is also going to be an ionic compound, so 2 sodium, and then 1 sulfate ion. Oh, no sulfate, no one required there, but anyhow. And so you have 3 ions here. Now, carbonic acid is a little bit weird one because carbonic acid is actually a weak acid. So you learned that in Gen Chem 1 about the weak acid. So which means that it does not really ionize all the way. So if it, excuse me for my voice, if it doesn't ionize all the way, then it means that it has some ionization. So what does some ionization mean? Okay, some ionization means that if you were to completely ionize this, you would have the 2 hydrogen ions plus the 1 carbonate ion. But because there is only some ionization and not complete ionization, it means that you have not 3 ions, maybe 2 ions, maybe 2.5 ions. And that is why we learned that Van 't Hoff equation when we do colligative properties to determine essentially like how many ions are we dealing with, okay, in this one. And that ions then becomes even a decimal point. It could be a 2.4. The VantHoffFactor can be 2.4 or 1.5, depending on how it's affecting colligative properties. Okay, so that is how you first start, okay, for any kind of question with the VantHoffFactor and how it affects the colligative properties. So now let's talk a little bit about how it actually affects. So we know that in colligative properties, the more ions you have in solution, the more it's going to affect that solvent. So the solvent, the boiling point of the solvent is going to be increased by more number of particles. If you have more particles in there, more solute in a solvent, then the freezing point will be even more depressed, okay, or even lowered. All right. So which means that when you look at all of these particles, and by the particles, I mean like all of these, how many particles are in solution? Well, now we have a competing thing here. So we have 3 ions here, and we have 3 ions here, which means that probably sodium sulfate and calcium chloride are going to cause the highest changes in the colligative properties. Okay, so they will cause the lowest or the freezing point to lower the most and the boiling point to be increased the most. Okay, that's how it works. And then followed by the 2 ions, okay, which is the HNO3. So this is going to be more than HNO3, which is then going to be more than the carbonic acid. So H2CO3 and then which is going to be more than glucose. Okay, because glucose we know for sure it is just one molecule. All right, so it's not going to have that much effect. Now for carbonic acid, I'm just taking a leap of faith here because, yeah, I don't know how much is going to be ionized in solution, but it's definitely going to be more than one because it's an acid and acids will ionize, okay, in solution. So this is kind of how we figure out the Van 't Hoff factor and how we also can determine how many particles or how the number of ions can determine the boiling point and freezing point properties. Okay, so just a little bit think conceptually, okay, that can help you understand how the number of particles is related to the colligative properties. All right, I hope that helped. Let me know if you have any more questions.